My name is Harry Pierson. I am the program manager on IronPython, and I'm up here to demonstrate the fact that program managers do, in fact, more than send email. You might remember me from last year. If you were here, I did a talk on parsing in F#. This year I'm here to talk about a debugger that I've been working on in IronPython. If nothing else, it should let you know how much fun I am at parties. So, a little backstory. I never was really much of a command line guy until I came to this team. And everybody else on my team lives on the command line. And so I pretty much had to get up to speed. And as you'll see, I've become quite a big fan of PowerShell. Also, of course, there's this little language that I work on called IronPython, which has this great REPL experience. And so I spend the vast majority of my day in Outlook. And the time I'm not spending in Outlook, I spend on the command line. Now, if I need to, I'm writing IronPython code all day, every day, when I'm not in Outlook. So I want to be able to debug that code. Now you can, in fact, fire up IronPython in Visual Studio. We emit full debugging information. If you pass -D on the command line, you can use it in any sort of managed debugger that's out there. The problem is that firing up Visual Studio for the purposes of debugging a 20-line script file that isn't doing what I'm expecting it to do is a pretty heavyweight solution, and it's not exactly easy to drive from the command line, which I'm trying to get into the mindset of. I spend all my time on the command line, and I've got this little electric shock thing in my mouse, so every time I touch it, I'm like, don't do that again. So I started looking around for other possible solutions, and it turns out that there's this command line debugger that ships in the .NET framework called MDBG, and we ship the source code to this stuff. And so I sat down and started to work with that. And MDBG is very cool, especially from the perspective that the source is available, but it doesn't know anything about IronPython. So for example, MDBG will automatically set a breakpoint on the entry point function in your executable, assuming you have debug symbols, which is great if you're debugging a C# application that you've compiled with debug. But if you're trying to debug an IronPython application, well, I don't have the debug symbols for IronPython installed typically. I mean, of course, I have like 8 copies of IronPython, some of which do have debug symbols. But I wanted to set a breakpoint on the first line of my script code. And the way you do that is that you go into MDBG, you tell it, I want you to break on the first thread or the first module gets loaded. And then I go in and say, I want you to create a breakpoint so it doesn't happen automatically. And then I say, OK, I want you to just continue. Don't tell me anymore that you're loading modules. And then I run. And I got tired of doing that after about twice. And I started talking about how can I go off and build a debugger that knows about IronPython on top of this same infrastructure. And it turns out that the MDBG is actually fairly cool in its layering. The lowest layer here is the COM API. So this isn't technically part of MDBG. Anything that starts with I core debug in the underlying framework is part of the debugger API. And there's more to MDBG than this. There's an extensibility model that's not shown on this slide. But at the lowest level, there's a DLL called raw, which is essentially pinvoke wrappers or declarations of all of the COM interfaces. Zero wrapping, just the C# declaration of all the COM interfaces. And then they have both a low-level and a high-level managed debugger framework. And then they have the actual application that's built on top of it. And so I sat down and I built 2 prototypes in C#, the first one against the high-level framework and the second one against the low-level framework. And I discovered 2 things. Number one, I like the low-level framework better. This isn't anything against the high-level framework. It's mostly about the fact that the low-level framework provides an eventing model. So when you hit a breakpoint, it fires an event. When you the step complete fires an event. And since I eventually hope to build a GUI on top of this, the event model seemed much more natural to me. The MDBG engine has this sort of looping construct. I never really got my mind around it. I didn't like it very much. So I chose to use the lower level API. The other thing I discovered about it is that even though this was written for C# 2.0, for the .NET Framework 2.0, that was, we invented things like yield and generics, this code doesn't use yield or generics. So you spend a lot of time, if you're writing in C#, casting, and there's a lot of the assembly there's like half the code. You look at it and you go, I don't need that, I don't need that, I don't need that. This all could be done entirely with yield and not have to build foo enumerator, breakpoint enumerator, app domain enumerator. You get the idea. And I was very worried that I was going to spend too much time saying, if I could just go in and add generics here, or I could just go in here and fix up this enumerator or whatever, that I'd spend all my time doing that and not any time actually working on the high-level API. And so I decided I actually would write the debugger itself in Python. So this is what my API looks like, or my the framework of my app looks like. Hello, there we are. Again, we have the low-level COM API. I took the raw and core API DLLs and combined them into one. Apparently the whole raw API, the reason it was separate was it was getting generated automatically out of TLBs or something back in 2005. So keeping it as a separate DLL didn't make any sense anymore. And then I'm building my own Python-based debugger on top of this. What's great about this is that you can, take this exact same code and say, well, I really like the low-level API too. You can just grab that assembly directly from this project and build a debugger for your own language on top of it. And this has actually turned out to be not a whole lot of code. I've got a fairly decently functional debugger in about 600 lines of Python code. Granted, some of that is related to the fact that Python is a very expressive language and a small amount of code, but a lot of it is also the fact that the low-level API is actually fairly powerful and does a lot of things for you. These are the features I've implemented so far. I have an automatic breakpoint on the first line, sort of like MDBG does, but I can also then add breakpoints, disable breakpoints, re-enable breakpoints. I've got sort of standard stepping in, out, and up. One thing that's not on this slide is the fact that I also have implemented something called just my code. As you can imagine, in something like IronPython, there's the code that you wrote, and there's a lot of IronPython infrastructure code that's running the code that you wrote. And so when I go to step into a function, I really don't want to step into the IronPython call site caching, blah, 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 blah. What I really want to do is just step directly into the IronPython code. And so I was able to implement, that was another actual reason for using the low-level API, is that the high-level API didn't implement just my code. So by working at the low-level API, I was able to invent that myself. So when I do steps, as you'll see when I get to a demo, there's a lot of infrastructure code that just gets skipped over completely. I've got stack trace. I'm able to show local variables. And of course, Python is an interactive language. It's designed to be used in a REPL console. So I actually have a REPL console today in IPyDbg. It's running in the debugger, right? So that's great for prototyping features. I actually inserted this code because I was having a lot of problems figuring out how to crack the local variables. And so I needed some type of interactive approach so that I could experiment and say, well, what if I do this? And what if I do that? Because I didn't know what was going on. The only way to figure it out was by experimentation. Obviously, eventually, what I'd like to have is a REPL that ran in the target process so that I can do that kind of function evaluation and run that in the target. But I don't have that running yet today. So let's see some code. Look, PowerShell, see? Are you happy, Jeff? Okay, good. So I have a quick thing. First off, see, look at this. Not even 600 lines of code. Activate Windows now. Yeah, that's really useful. Here, go away. Again, this is entirely written in Python, except for that fairly significant amount of code that I stole from the NDG project, which is all written in C#. I won't show you any of that code. I'm not really going to show you much of this. I did want to show you a couple of quick things. One of the things I love about Python, which this hasn't really much to do with debugging, excuse me if I can find it, is these support for these decorators. Python doesn't have a switch command, so my early versions of IPyDbg had a, if the user presses this key, do this. If the user presses that key, do that. If the user presses, and after you write 4 or 5 of those, you're like, this is getting old. So input command is a decorator that automatically maps a specific key, in this case R for invoke the REPL, and puts it into a dictionary so that in my input command I can just sort of say, the user pressed a key, look it up in the dictionary, and if it's there, dispatch it to this function. You'll notice actually in the code right above that, I've actually got 2 of these dictionaries. I've got one for my main input loop and a second one for my breakpoint, because when you hit a B for breakpoint, you're entering into sort of a separate mode. I'm very, very frugal in my keystrokes for this project, which is just a sort of interesting user experience design point. I figure I'm twice as productive because I don't have to hit like, S for step and then hit return. I just hit S and it steps to the next line. So let's see this running here in action. So I have a little PowerShell function that sets up a couple of automatic things for me with IPyDbg. It's just well, I'll tell you what, I'll run it once without that. So I'm running, this is IronPython 2.0. It's not running in 2.6 yet because there's a COM interrupt bug, and I'm not sure if it's been fixed yet. And of course, the debugging, the low-level code that gets generated varies from version to version. So I'm going to have to make some changes to this in order to make this work in 2.6. And then I just pass in the name of a script that I want to bring. It takes a second to fire up. The debugger is not known for its massive speed and performance. That's why you don't run it in production. And you'll notice that I'm getting a bunch of events. As I mentioned, the event-based API I found very clean and very easy to work with. I'm loading domains, I'm loading classes. The reason I'm overriding these events, I need to, on app domain, is when I set that initial breakpoint. On class load, I'm setting just my code. I need to be able, whenever you load a new class, I need to look to see whether it's class code that's dynamic that I want to mark so that I can step through automatically. And then in the on update module symbols is when the runtime tells you, hey, here's some new debugger symbols, right? Again, in IronPython, unlike C# or something, there's no PDBs on disk. That information is getting handed to you in memory. All that information is getting generated in memory, so it gets handed to you. And then you'll see here that I've hit a breakpoint in one test py, and this is what the line of code looks like. If you want to see what this incredibly difficult program looks like, it's going to add two numbers. It's very powerful. I can see a stack trace. This is the faked stack trace. This is only a stack trace of the things that are related to my project. If I hit Alt-T, this is what a real stack trace looks like. So you'll see that I've got a bunch of this infrastructure stuff, IronPython.hosting, Microsoft.scripting. I'm basically just filtering anything that starts with IronPython or Microsoft scripting does not show up in the normal stack trace, but I can always get it by hitting Alt-T. So if I step in, I'm stepping into my add two numbers function. I can hit L, and I can see that I've got two local variables. These are the arguments that were passed to the function. I can also hit Alt-L here and see, I can see that I've got a $. Python will emit a bunch of local variables that are used for, again, for sort of state keeping and record keeping, what have you. Those are all prefixed with a $. So again, I hide or show based on whether or not it has a $, and whether I hit the Alt key. If I step again, this is actually sort of an interesting design point. The breakpoint will end. This is the last, sort of point in the function before I'm about to step out. In C#, you would map this, to the curly brace at the end of the function. There's no syntax in Python that you can see for the end of the function. So I did this sort of, 3 arrows up to sort of indicate, okay, this is the last chance in this function that you're going to see before you step out of this scope. So as you can see, if I hit L, I get the two integers. If I step in again, I get the two numbers, and it says there's no locals found. Again, of course, there's a bunch of locals that are hidden. And then I can continue. I'm going to run a separate program here. This one is just setting a bunch. I mentioned that the local variables is very sort of difficult to work with. In the underlying debugging API, it is very well aware of some low-level constructs. The debugger API knows about integers of varying types and sizes and signages. It knows about floats. It knows about strings. It knows about arrays. The problem is that if you take one of these primitive value types like integer, it knows about booleans and chars as well. But if you take them and you box them, suddenly the debugger forgets what that thing was. It's like, well, it was something, but now it's just a random value type. So what I wanted to be able to do is to be able to say, if I step in here, I'm going to set a bunch of properties. You'll see that I've got, here I haven't gotten to setting F or G, so they're none, they're null, and it's just a system.object. And these were all, when I entered into the scope, they were all none. But now I've specified a string and a double and a Boolean. I actually have to go and look at the .NET type and reverse engineer that in order to be able to figure out, gee, I want to be able to display that on the console because the debugger has forgotten because I boxed the type. In IronPython, all values are boxed all the time because we work everything on objects. So this was about 5 hours banging my head against the wall in the airport while I was waiting to go to PyCon to figure out. I mentioned I have a REPL loop, so you can see here that I've got, I can sort of say, whoops, I can see I've got my, this is the IPyDbg process object, so I can see self.active thread.active frame.get IP, and this will get me the instruction pointer. I'm not quite, my parsing isn't quite smart enough to figure out yet that I don't have a compound statement, so I need to fix that. Yeah, sorry. So, but this is just this is just a standard REPL loop. Again, just executing Python. It's just a series of compile and exec functions. This is about 15 lines of code entirely. Oops, and then I need to exit out of that, back into the IronPython debug. Again, I wanted to show real quick. So this is my dynamic stack trace. Initialize is sort of the entry point. I'd like to be able to map these to real Python names. These are the sort of underlying C# function names. You can see it's foo $335. That's a generated name. I know that comes as a huge shock. If I show you the real stack trace, you'll notice that there's 4 functions that live between the call from initialize to the call to foo. So when I did that step in from initialize into foo, it skipped over these additional frames because they weren't marked as just my code. And that makes a huge difference from a debugging perspective. I'm looking at adding the same kind of, the alt key I'm using for show the full stack trace, show the full locals as a, I want to step not into just my code, but I haven't implemented that yet. Today, you pretty much only jump into Python code. And then the last is it also works with additional modules. So this is a test that's using, I wrote this library for IronPython called XML to Py that will automatically bring XML in and parse it into Python. So you'll notice as I step here, you'll see I'm about to import, I'm going to import from devhoc import IPy. If I step into that, then I'm going to be, right now I'm in init under init.py. That's empty, so it just returns immediately. But now I'm in XML to Py, so I'm able to step into this other project that was loaded from the original project. So all of that sort of relative loading of Python modules, all of that stuff works exactly as you would expect. And then it's just going to sit there and load, and this just shows a bunch of recent posts from my blog. Very exciting. So Jimmy is waving at me, so I'm going to go back to my, whoops. Things I'd like to implement in my copious amount of spare time. The big thing is related to function eval. I haven't had a chance to implement func eval yet, so I cannot execute code in the target process. Once I do that, it opens up a lot of very interesting scenarios. Obviously, I'd like to get a REPL working in the target process. I'd also like to be able to use built-in Python operations like local and globals. Rather than asking the C# code and sort of trying to figure out, what are the locals, what are the globals, it'd be nice to be able to walk up to the Python code and just execute these standard Python functions in order to get that information. I have a string representation for those primitive types, string, integer, float, what have you, but I don't have a string representation for the standard Python types, most notably dictionary, list, and tuple. As you imagine, a lot of Python code spends a lot of time with those 3 types. It'd be really nice to be able to see those as string representation right there in the console. For other types, I want to be able the ability to drill down into them or to call toString on them or something like that so that I can get something other than this is some object I don't know about. And as I mentioned, I am very interested in building a GUI. I figured that as the IronPython PM, I'm responsible in part for doing, here's IronPython with insert random Microsoft technology here. And I started a whole series of IronPython with WPF. I was doing a photo viewer because that's what you do with WPF is you make photo viewers. That's apparently a fantastic technology for viewing photos. And unfortunately, I was using the Windows Live photo RSS feeds, and they changed, and I haven't had a chance to go back and fix up my code. So I thought, wouldn't it make more sense for me to be spending my time showing how to build a WPF code for building a debugger than yet another photo viewer? So at some point, I'm going to try to get to that. Otherwise, some quick resources. My code is available entirely online, including a fork of the original core debug MDBG source code. I've made a few small changes to it, small targeted changes to make it work in a few things that it wasn't doing correctly before. If you want the real source code, there's a really long, ugly URL for it, or you can use this nice tiny URL. Mike Stahl works one floor below me, and he will be sure to tell you that I've spent a lot of time bugging the crap out of him, asking him how to do things. Unfortunately, not everybody is able to work in the same building with Mike, but you can all read his blog where there's lots and lots of great information about how to work with the debugging API, including some great stuff about how to emit debugger information. One of the things I love about this conference is learning about all the great new languages that are coming out on the .NET framework. It'd be great to see, hey, if you're emitting standard debug information, you can plug into Visual Studio or into any of these other tools and get a good debugging experience. And finally, my blog is devhawk.net. Feel free. I've written like 18 articles on this so far. I'm taking a bit of a break from it for a while, but I will be back to it. So with that, are there any questions?
Do you know if anyone's done, or if it's possible to implement the COM requirements for this kind of stuff on Mono?
Has anybody implemented the COM API for Mono? I have no idea what Mono's debugger API would look like. I'm not familiar with it. I'm not sure I would try to mirror this API, to be perfectly blunt. So it's, the reality is it'd be really nice if, one of the things we run into is there's a standard debugging process or a standard debugging tool in Python called PDB, which of course gives you sort of TLA collision, but that's Python debugger, not program database. We don't do set trace because the way we do stack traces or stack frames is different. So we can't use the standard Python debugger. That would be, I think, I don't know. I have a hard time imagining that just given the COM aspect and having to go through and implement all of that type of infrastructure in order to build a debugging API that would match this, I don't know whether Mono would even want to do that. Now, granted, I have no idea what Mono's actually done in this space. In fact, you, Jim, probably know much more about it than me since you guys are using their stuff. Jimmy.
As a Lang.net coordinator, are you aware that you are 5 minutes over your...
I'm 3 minutes over, and the person who's coming up after me isn't up here, so he can come up and start plugging in, and I will take questions until he's ready. I'm not that scary. I'm great at parties. Didn't we just address this? I can talk about parsers and debuggers all day. Brad. Thread switching. The low-level debugger API doesn't have any knowledge of like sort of what thread. It's like whatever event raised whatever thread you were on that raised the event is passed to you in the event arguments. So I'm taking that and stashing it away in that. In fact, if you saw in my REPL, I said self.activeThread. Well, that's just grabbing the thread that when I hit an event, I stash the event variable away as a variable in my object. But there is a threads collection, so you can walk all over that and do whatever you want with it. For Python, most of the time, for the type of stuff I've been doing so far, it tends to be single-threaded. Of course, IronPython, Python has the global interpreter lock in the CPython version, so you don't see a ton of multi-threaded Python code. We, of course, don't have that problem in IronPython, so you can spin up threads and do whatever the heck you want. So it would be an important thing to have. I haven't run into it. This is basically the same model MDBG uses. I just sort of cloned it for this.